Hey everyone, let's talk about section 2.3, calculating slope. To calculate slope, we can use the formula m is equal to y2 minus y1 over x2 minus x1. That's the change in y divided by the change in x. So over here we have the points 3, 2 and the point 5, 0. And I'm going to go ahead and I'm going to start with 0. That's where the y ended up. So it's going to be 0 minus, and then I'm going to subtract from that 2, where the y started. I'm going to do the same thing with x. I'm going to divide this by 5, where the x ended up, and I subtract from that 3, where x started. So we do this arithmetic, negative 2 over 2, the slope is negative 1. And again, m is the abbreviation for slope. For a line like this, 2y plus 3x is equal to 7, what I'm going to do is I'm just going to go ahead and solve and get this into y equals form, get this into slope-intercept form. So 2y is going to be equal to negative 3x plus 7, and then y is going to be equal to a negative 3 halves x plus 7 over 2. And this right here, the number that's multiplying x, that's my slope, so my slope is equal to a negative 3 halves. And for a line like y is equal to negative x plus 6, I can just read the slope directly off. The slope is a negative 1. We don't have to find points, but we can use points to find the slope. Okay. Now, I mentioned point slope in 3, 2, 1. Point slope form is the form of a line where we have y minus the y coordinate is equal to the slope times x minus the x coordinate. And what we want to be careful with here are these parentheses. We want to be sure to include the slope for x in the parentheses. Excuse me, the slope, the value, the coordinate for x in the parentheses. So I'm going to start off for this line. I'm going to do y minus and then m equals parenthesis x minus parenthesis. Okay, the y coordinate is 1, so this is y minus 1. The slope is 6, so it's 6 times whatever. And the x coordinate is 3, x minus 3. So that's everything written out in point slope form. And then, you know what, if I take this 6 and I distribute it right, we'd get what? 6x minus 18, and that would be equal to y minus 1. And that negative 1 out there looks kind of weird just hanging out by itself. So we add it to both sides, and we get 6x minus 17, and that turns this into slope-intercept form. Y equals mx plus b. So for point slope form, I can start off with a point and a slope. I put it into this equation, and if I wish to, I can solve and manipulate to get it into slope-intercept form. There's another example. If my slope is equal to 2/3 and I'm looking at the point, let's make this negative 3 comma 7, then I would have y minus 7 is equal to 2/3 x plus 3. And this plus 3 is actually minus a negative 3, right? So this becomes y minus 7 is equal to 2/3 x plus 2. So y is equal to 2/3 x plus 9. and I could then read off the slope if I needed to, and I could read off the intercept if I needed to. Great. Speaking of slope-intercept form, let's take a look at slope-intercept form. The slope-intercept form of a line is the form y is equal to mx plus b, where m is our slope and b is the y-intercept. So if I'm given the slope and the intercept, then the equation of the line for this would be y is equal to 8x plus 3. I could then take and find the x-intercept by putting 0 in for y. 8x plus 3. Negative 3 is 8x. Negative 3 eighths is equal to x. So that's the point negative 3, 8, 0, x intercept. I could graph this line by taking, and let's see here, let's get a little bit of axes. And starting off at 3, and then going up quite steeply, it looks like. So this would be the point, x is 0, y is 3, and then if I went over 1, this slope right here, that slope means that an increase of 1 in x goes up by 1, y goes up how many? 8. So this would be the point 1, 11. And that'd be a reasonable enough graph. If I had tick marks, a grid, I'd actually count it out, but I can draw something like this. And remember that 8 right there, this is quite steep. Now, if I have 2 points, like let's say 2, 1, and then let's make this 3, 1, and I want to graph them, that would look something like this. Draw my line, see here, 2, 1, 1, 2, 1, there's that, 3, 1, 3, 1, there's that. Connect them. That's a nice little horizontal line. And see how y is 1 right here and y is 1 right here? Y is going to be equal to 1 everywhere. And that's actually the name of that line, y equals 1. So a horizontal line has the form y is equal to some constant. And actually, we could call that constant not just a, but we could call it y is equal to b right there, because this 1, 0, 1, that's the intercept. It never crosses the x-axis unless we have y equals 0. And its slope is 0. The slope is 0, the slope is flat, it's horizontal. So that's a horizontal line. What about a vertical line? Well, a vertical line would be the opposite. If in a horizontal line we have x changing, in a vertical line what would happen is we'd have something like 4, negative 1, and 4, 3 as our points, right? And then we could go ahead and graph that on our axes, and let's count out 1, 2, 3, 4, negative 1, 1, 2, 3. So here's 4, negative 1, here's 4, 3. And we connect those 2 points with a line. and that's the line x equals 4. Because as you can see right here, this is x, it's 4. This is x, it's 4. X equals 4, that's the name of its line. So the form for a vertical line is x is equal to some value, call it a, because this right here, that's our intercept, the x-intercept at that point. So as the form x is equal to a equal to some value, and its slope is undefined. It doesn't have a slope. Its change in x is non-existent, right? And remember, for our slope, it's the change in y over the change in x. What's the change in x right here? It's 4, and it's 4. The change in x is 0. There is no change in x. So I don't know what the change in y is, but I know that the change in x is 0, and we can't divide by 0, so that slope is undefined. There's this idea for the standard form of a line in the textbook, and that's something like, what is it? Ax plus by plus c is equal to 0. So we could have something like 8x plus 2y plus 16 is equal to 0. And then we'd have to get out of this all the information we want. This is kind of a lousy form of a line. The text maintains that any line can be written in this fashion. That's alright, but it's not a practical way to write a line. Sure, you could always encounter it for any type of line, but I mean, first thing we do is we get y by itself. Not Slav, solve for y. Solve for y. We're going to get y by itself. So that's 2y plus 16 is negative 8x. 2y is equal to negative 8x minus 16. Y is negative 4x minus 8. Okay, so then from here, what do we know? M is negative 4. And we happen to know right here b is negative 8. So if I wanted to graph this line, I'd go all the way down here to negative 8, right? 1, 2, 3, 4, 5, 6, 7, 8. There's negative 8. And then it's again going to be quite steep. So let's make a line that goes quite steeply down through that. How do I know it's decreasing like that? Negative. And then what's this point right here? Well, I put 0 in for y. And we get, you know, I could put it into here, or I think I'm going to put it in right here. 8x plus 2 times 0 plus 16 equals 0, just in case I made a mistake. So 8x is equal to a negative 16, x is negative 2, so this is the point negative 2, 0, that's the x-intercept. And we said this was what? 0, negative 8, the y-intercept. And I think that's just about everything for this line. That's the y-intercept, the x-intercept, and the slope. So if I've got a line like this, the first thing I'm going to do is probably rewrite it like this into slope-intercept form. How do you graph if you've just got the intercepts? So I think I just showed you that in that last example. We took and we found the intercepts. We knew it was going to happen at negative 8. I counted down to negative 8. And I knew the line was going to be kind of steep like this, but I didn't know where it was going to intersect. So I found that x-intercept and figured out where it was going to intersect the line. Let's take a look at another example and figure out graphing with just the intercepts. For this line, let's take 2x minus 3y minus 6 is equal to 0. And let's solve that. So minus 3y minus 6 is equal to a negative 2x. Minus 3y is equal to negative 2x plus 6. Y is equal to positive 2/3 x minus 2. Great. That's a slope-intercept form. And I can see right here that b is equal to negative 2. But I could have set x equal to 0 and gotten 0 minus 3y minus 6 is equal to 0. Minus 3y equals 6. Y is negative 2. So that's the point 0, negative 2. And then done the same thing with y equals 0 and get 2x minus 0 minus 6 is 0. 2x equals 6. X is equal to 3, and that would be the point, let's write it right here, 3, 0, right? And then we take our nice little grid, and I'm going to plot out 0, negative 2. So 0, negative 2 right there. And then 3, 0. 1, 2, 3 right there. And then you know what I do? I just connect them with a line, and that would be the line y is equal to 2/3 x minus 2. And this is 3, 0. And then this is 0, negative 2. And I label my graph, and everyone knows what's going on. So I find where on the graph those intercepts are, and then I connect them. And remember, when we're solving, when we're trying to find the intercepts, it's y equals 0, x equals 0 to get those intercepts.